couple things on the vocabulary. We have the index. We have the radicand. Yep. We have the root. And we have the radical sign. The biggest thing with this is once you take the radical of the number, that's done. It's a one operation and done. So for example, if you were adding two things together, you don't just keep adding and adding and adding. Once you add them, you're done. So it's the same thing with radicals. The best way to look at it is the index can tell you how many groups of that you're looking for. Okay? So the fourth root of 16. In other words, in this case, 2 to the fourth power is 16. So if I were to multiply 4 2's together, I would get 16. So the index is telling me group of 4 in this case. So here, it's asking what number raised to the third power is equal to negative 27. Negative 3. Because if we take a look at that, negative 3 to the third power is negative 27. You multiply 3 negative 3's together. So that index is indicating we want a group of 3 things. So what number raised to the fifth power?
1.
Yep. And we're dealing with 4 on that. Because 4 to the fifth power is 1024. So this index indicates I want a group of 5 things to make that happen. Okay. We'll be working with radicals for several days on this. Today, everything will be completely simplified under the radical. After we get past the mid-chapter, we're going to be seeing some things left under the radical because not everything's going to be able to come out. So let's take a look at that. This is your more definitions. So we have the nth root, meaning any index outside of just the square root. Even versus odd, what they have as options. But let's take a look at this. 49 z to the 8th. We are dealing with a square root. So I can break this up. 49 is 7 times 7, and there are 8 z's. 5, 6, 7, 8. That's what's really going on there. My index is 2. So let's take a look at how many groups of 2. I have one group of 2 on the 7s. I have 1, 2, 3, 4 groups of 2 on Z. I show this way because this translates really well to the next two lessons after it. Looking for what comes out from the radical and what stays underneath.
So if there's like, if you can't see an index, it's 2.
Yes, exactly. So the index is understood to be 2 when there's not something written, a square root. So on example 2, we have a third root of that. Please do not multiply that out. But let's take a look. I have 6 of those things, right? So technically, I have 1, 2, 3, 4, 5, 6. Now, I don't know about you, but I really don't want to multiply that out. My index is 3, so I'm looking for groups of 3. I have one group of 3 there, and I have another group of 3 there. So that's a negative. And we're done. The negative just sits out in front, adds a -1 times that, and we just leave it alone. Anything you're seeing with the exponents that we might be able to shorten and not have to write some of that out?
5 by 2.
We can do what?
6 divided by 3.
Ah.
Divided by 2.
So our index is 2. 8 divided by 2 gave us 4. Our index is 3. So 6 divided by 3. And that's exactly what works. Because when you're writing index versus exponent, (49) z to the 8th to the 1/2 power. So the denominator of this fraction is the index. So something you can be working with and using here. So just like now we're dealing with the power rules. So that's 49 to the 1/2 and z to the 8/2 because you multiply the exponents, power to a power. Well, square root of 49 is 7. 8 over 2 becomes 4. So the fractions is something we'll work more with in a couple of lessons, but it is definitely helpful here with these exponents. Okay. All right. So example 3 and 4. Again, I have a square root. So with that, any signs in front of the radical, we're just going to leave them as they are. So 36 is 6 times 6. And I have 10, 6, 7, 8, 9, 10 x's out here. With an index of 2, that means I'm going to need groups of 2. So 6, 1, 2, 3, 4, 5. Or 10 divided by the index of 2 is
5.
5. Okay. The only difference is I need absolute value around that. Because around the x to the 5th. If I take a negative number to the 5th power, that number is still negative, correct? But can I take the square root of a negative number? No. So that's what that absolute value is doing, is it's protecting when you have an even index and you end with a odd exponent. Even index, end with an odd exponent, you need absolute value. Okay? It can even happen with those. Because again, I do not want to multiply x minus 3 out 12 times. Please don't do that. But the 4th root of 16, what to the 4th power is 16? No, that's squared. So,
2.
yep. I'm not writing that out. All right, so 2. I'm going to do the trick with the exponent. 12 divided by 4 is?
3.
Exactly. Even index. Odd exponent. You need absolute value. And when you get your final answer, you still don't have to multiply that out. Just leave it with the exponent on it. The goal here is to see, did you simplify it correctly with those exponents? Okay, so when do we use it? Even index. So, for example, the 4th root of x to the 12th. And that becomes x to the 3rd. That is the only time you use it. And just keep in mind, you need to, because you cannot take the 4th root, square root, any of that of a negative number. So even index, odd exponent, needs the absolute value. Nothing else. Okay. What's the square root of 81? What is the 3rd root of negative 343? Negative 7. So again, keeping that in mind. Okay, we got a couple things going on 3. We have the square root of 144, which is 12. Then we're going to have 6 divided by the index of 2, which is, so p to the 3rd. Even index, odd exponent, we need absolute value. If there are signs in front of the radical, just drop them. Just copy them right on down. Square root of 4 is?
2.
And, yep. 10 divided by 2. So a to the 5th, even index, odd exponent, absolute value. see what you can do with the next row.
If it's an odd index, an even exponent, no good.
Nope. Because you can, just like we showed on number 2, you can take an odd index of a negative number. That can happen. So if it's odd and ends up with something, then you're fine. All right. The fifth root of 243 is 3. 10 divided by 5. Okay, the next one. Again, the negative just travels with it. So I have 6 divided by 3, which is 2. 9 divided by 3, which is 3. So we're still going to be able to follow the same thing in the next lesson if not all of it comes out of the radical, because the remainder, you'll get a remainder. So that extra just stays underneath. All right, so I have the third root of a negative number. Essentially, this is the third root of negative 1, b to the 12th. So the third root of negative 1 is negative 1. 12 divided by 3 is 4. So there's two things going on there on 7. You have a negative 1 and you have b to the 12th. So the square root of 16 on 8 is 4. 10 divided by 2 is 5. 8 divided by 2 is 4. So we only need absolute value around that. If you put it around the A and the B, that's not going to hurt anything. But it technically only needs to be around the A. Because, for example, negative 1 to the 5th power is negative 1. Negative 1 to the 4th power is positive 1. So it makes the negative go away on that one. All right. So I have the negative that travels with it. The third root of negative 27 is negative 3. 6 divided by 3 is 2. Now I'm going to simplify this. Negative 1 times a negative 3 is a positive 3p squared. See what you can do on the rest of those in that row. Okay, let's take a look. Negative just travels with it. The square root of 625 is 25. On y, 2 divided by 2 is 1. On z, 4 divided by 2 is 2. So I need absolute value around the y. Even index, odd exponent. On 11, the square root of 36 is 6. 34 divided by the index of 2 leaves us with q to the 17th. So that needs absolute value. On 12, the square root of 100. 10. On the exponents for x, 2 divided by 2 is 1. On y, 4 divided by 2. Yep. And on z, 1, because we'll have 2 divided by 2. So we have two cases where we have odd exponents left after an even index. Okay. $13. So even decimals can be simplified with this. Because again, and keep in mind, that is negative 0.3 times negative 0.3 times negative 0.3. So that was the same number multiplied. So that's just a negative 0.3. Can we take the square root of a negative number on 14? No. So this, because that is a negative number that we're trying to take the square root of, no real roots. That's not possible. If we're trying to find the real root, which is what we're trying to do, we're not going to use imaginary numbers here. Okay? There are no real roots, so that's how we're going to list it. Okay, so on number 15, I can certainly take 2 to the 8th power and x to the 8th. However, I can just divide this 8 by 4 and just have 2x squared, which is 4x squared. So don't make this more difficult than it needs to be. So just like on 16, I don't need to do anything with the inside of that. I just need to take this 4 and divide it by the index of 2. So I have 11y squared now, which is 121 y to the 4th. Use your properties of exponents, which is what we're doing when we take the exponent and divide it by the index. Don't put extra work on the stuff. So when you see exponents like that, use those properties. Okay. See what you can do with the first 3. We'll take a look at 20 together. Okay. Again, I can certainly take 5 to the 6th power, but I'm just going to work with 6 divided by the index of 3, so that I have 5a squared. So that becomes 25a to the 4th. So if you have a single monomial, the expectation is that you're going to use your power rules and simplify that final answer. So on 18, I have an exponent of 2, and I'm going to divide it by 2. So that becomes 3x minus 1 to the 1, even index, odd exponent. So all of that needs the absolute value around it. On 19, I'm going to take the exponent of 6 divided by 3. Don't multiply that out. Unless you just really want to, but don't. Because from that answer, I can clearly see you followed the correct rules to simplify that radical. All right, number 20. Well, if they give you a trinomial like that, you can expect to see something like number 18 underneath it. So I'm going to factor that trinomial. So I have 36x squared minus 12x plus 1. So what multiplies to 36 adds to negative 12? Exactly. So the same two numbers, and that's what I would expect to see. So 36x squared minus 6x minus 6x plus 1, and notice we never get away from our factoring. It shows up everywhere. Factor that by grouping. The first two I can divide by 6x. When I do, it leaves me with 6x minus 1. The next group is almost 6x minus 1. So I factored in -1 to switch it to a positive 6x minus 1. So I have 6x minus 1 and 6x minus 1. I add the same two factors, which means I can write it the square root of 6x minus 1 squared, indicating I have two of the same factor. So now, like 18, 2 divided by the index leaves me with a61, 6x minus 1. You can put parentheses around it and then the absolute value, or you can just put it as 6x minus 1 with the absolute value on either side of that. Either way works. Okay? So when you see trinomials like that, then know that there's some factoring to get you down to the same two factors. All right, some word problems. Anytime you see a word problem, they're going to give you a formula or an equation to use, and you're going to put what they give you into the formula. So the formula used by police to estimate the speed someone was going by the length of the skid mark on the road. So slammed on the brakes, your tires are going to make a mark on the road from that. Estimate to the nearest tenth of a mile per hour the speed of a car if this is the length of the mark on the road. So does 300 go in for L or for R? L. So R equals 2 times the square root of 5 times 100. Oh, 300. Just kidding. 5 times 300. So that's 2 times the square root of 1500. So that car was traveling nearest 10th. So 77.5 miles per hour. So you can try and lie all you want. Hey, no, I was really going this fast. And they've got ways to figure that out. How fast you were really going, estimating that. Okay. So number 22, space travel. The distance to the horizon from a satellite orbiting above the Earth can be approximated by this equation. D being the distance to the horizon, and H being how high it is above Earth. So here's our number. We know the satellite is orbiting 150 miles above the Earth. So that's going to go in for H. 8,000 times 150 plus 150 squared. So this is where you want to be very, very careful. And not trying to necessarily do too much of the work at the same time. So underneath the radical, I'm going to take the square root of 1,000 to, or 1,222,500. Wow. They do not tell us what to round it to. So I'm just going to go with if they don't tell you what to round it to, I always just go 2 decimal places because that works for everything, including money. Any questions? So it is 1,105.67 miles from the horizon. So in other words, where it's no longer going to be viewable as it goes orbits around the Earth. Think about kind of like the setting sun. At some point, we can't see it anymore because it goes beyond our horizon. All right.